Good morning, sir.
Good morning. Recently, I come across the Daksh for Faculty AI Hackathon,
Yes.
where several AI driven solutions were proposed to improve the classroom teaching and student mentoring.
Yes, sir. Actually, I have also gone through the problem statements, sir. So the problem statements included ideas such as dynamic case study generation and then Socratic AI tutors, adaptive scaffolding quizzes, and early detection of at-risk students. It inspires a lot, sir.
Exactly, these themes actually inspired us to think about how AI can support both teachers and students in more integrated way.
Yes, sir.
Okay, ready for the demo?
Yes, sir.
But before we are jumping into, I think it might be interesting to talk a bit about why we are even started working on Sarvajna AI.
Exactly, sir. Because the idea really comes from something we kept noticing on a daily basis, sir. So, as an academician, we used to upload a lot of materials like PDFs, slides, but still students are struggling to actually study from them, sir. Also,
Yes,
students are facing day-to-day difficulty in grasping the concepts too, sir.
yes, that's true. The information is true, but it might not be always easy for students to process it in the way they prefer.
Right, sir. Some students want quick summaries, and some might prefer detailed explanations, where other could understand better through visual representations.
And from the teacher's perspective as well, preparing students' notes, answer keys can take quite a bit of time.
Yes, sir. Also, we feel that the students' learning pace should never be forced, no, sir. So, learning should inspire curiosity, but not on pressure. Also, it should grow through self motivation. So, the best learning happens only when curiosity leads and practice follows, sir. So that's where Sarvajna AI comes in, where wisdom meets intelligent learning, sir.
Okay, let's see the demo.
Sure, sir. Thank you, sir.
Sarvajna AI is built using a random scalable AI architecture where the backend is powered by FastAPI, MongoDB, React with White, and Google Gemini AI to create a fully adaptive learning platform. So thus our Sarvajna AI achieve this such that instead of forcing the students to adapt to the system, our system adapts to the student. Let's dive into the demo. When the user registers, the password is never stored as plain text. Instead, the system is secured through PBKDF2 hashing with salted hash 256, and then the password will be stored. After login, the system creates a JWT based authentication token which is validated for every API request to ensure that the role based access control. Here we have two role based access control. One is for teacher and another one is for students. So students and teacher can see different dashboards where the teacher can access the content orchestration tools while the student access learning and practice modules. The Sarvajna Academic Hub acts as the session orchestration layer where here the teachers can deploy new classroom by specifying the subject and the section. When a classroom is created, the backend generates an unique access code and stores the classroom record in MongoDB, and then the students can use this access code to join the classroom. AI pipeline starts here. So this is the upload section where teachers can upload the lecture materials such as PDFs or PPT files. Once uploaded, the backend processes the document using a file processing module, and then it will be passed through LLM model pipeline to identify the key concepts, learning objectives, important topics from the document. So here the faculty can upload their materials directly from option 1 where they can generate their own materials by requesting or by prompting LLMs. say for example Gemini LLM according to their add-on customized content, and they can be change the content if needed. So they can directly upload the document by getting the PDF through LLM itself. So say for example, a faculty can log into Google Notebook LLM directly, and they can prepare the PDF or PPT content by preparing a slide deck by prompting the AI, and then prompting, and they can download the PDF or PPT material, and they can upload it directly from option 1. Whereas in option 2, the faculty can use an AI generation option where the AI will generate structured outputs like summaries, study guides, mind maps, logic graphs. So the outputs will be stored in the database and made accessible to the student. So we have implemented the part of uploading the materials and get the answer key for the question paper which we are uploading. Right now the work is under progress. So after analyzing the material, the AI generates assessments questions automatically. So the system creates MCQs, conceptual quiz questions, coding challenges for programming, and topics automatically. Here, for coding arena, coding challenges can be created by the faculty for the topic they are taking on day. So what they can do is they can click the coding challenges and click AI generate such that the coding challenges will be generated. So it will be of interactive coding environment where it will be generated automatically. Or if the faculty wish to upload the material, and if he or she wish to manually conduct the coding classes, based on this analysis, AI generates coding challenges which includes a problem statement, instruction and hints, and then a starter code template and predefined test cases for it. We have also provided quiz analytics tab for the teacher to monitor the student progress individually as well as the classroom progress as a whole. So this helps the teacher to analyze the individual ability of the students. So here the student can log in. So when the student logged in, the system verifies the credentials through the backend authentication service. After that, student can join a course using a unique classroom code provided by the faculty. When the student enters the code, the front end sends a request to the backend point. So the backend verifies the classroom code in the database and then registers the student under that classroom record. This ensures that the student can get access only to the learning materials belonging to their enrolled classes. So once enrolled in the classroom, the student can access the learning materials uploaded by the teacher. So these study materials are not simply shared files as I have explained before in teacher's dashboard. Rather, the backend performs AI-based knowledge extraction. So based on semantic analysis, the AI system generates multiple learning representation, which allows the student to view the generated structure summaries and then study guide documents, mind map, and logic graph. So the student can view any of these as they have any preference over that. The motivation behind generating multiple knowledge representation is that every student has a different learning experience. So some students might prefer detailed explanations, but while others might prefer mind maps or logic graphs that helps them quickly grasp the concepts a day before examination. So this may act as a visual analogy creator or the dumb question classifier. Additionally, it can be reference. So this is the example for engineering physics mind map, and this is the example of the snapshot of logic graph. And for coding kind of subjects, we have uploaded C programming, and we have viewed the mind map and the logic graph of the same. So here you can just go through that. Explore the assignments and the MCQs tab in the student dashboard. So here, after analyzing the material, the AI generates assessment questions automatically from the faculty side. So here, if the faculty wish to upload their own questions, they can upload in the manual options as in coding arena I have told you. So they can choose the difficulty level accordingly. So now I'll demonstrate the scaffolding quiz mechanism implemented in Sarvajna AI. The objective of scaffolding is to guide students from basic understanding to advanced problem solving skills rather than presenting difficult questions immediately. So when the student enters the quiz environment for the first time, the backend checks whether the progress record exists in the database. If not, the system will automatically initialize a student progress profile. So this progress object tracks the learning and the current difficulty level, and then number of correct answers and quizzes. So the teacher can view the same also. Here the system implements adaptive scaffolding algorithm. Initially every student starts at the beginner or easy difficulty level. The backend continuously monitors the student performance through progress tracking module. If the student answers multiple beginner level questions correctly in sequence, the system will automatically upgrade the difficulty level to medium. Then if the system students continues to perform well, then it escalates to hard. This is achieved by tracking the current counter in the student progress database, and it will be auto updated according to the difficulty parameter when the threshold is reached. This progressive difficulty transition ensures that the students is neither overwhelmed nor under-challenged, so thus creating a personalized learning trajectory. Same applies to coding arena for programming subjects and subjects like engineering design, engineering physics. They can have tabulation based questions too here. Each coding challenge also include an optional hint system. If the students get stuck, they can reveal the hints that guide them towards the correct logic without directly giving the answer. This helps the students think through the problem while still receiving the guided support. If the company is purely a coding based one, these karma points based on the coding really helpful since it is evaluated by an AI model. So here comes the quiz analytics tab where the analytics part comes in. So here what happens is each time a student successfully completes a quiz or coding challenge, the backend will award karma points based on the difficulty level and the accuracy of the solution and the solution correctness and the completion speed of the student. So what happens here is these metrics are stored in the student progress database, as well as it will be visible to the faculty who is handling that particular subject, where it helps in analyzing the sprints. So our platform combines dynamic case study generator, dynamic learning environment, adaptive scaffolding algorithms for quizzes, AI generated assessments and behavioral learning analytics to personalize the educational ecosystems, which is for every student. So from faculty perspective, answer key generation based on question paper, material customization with PPT, thereby they can have a significant reduction in their manual workload involved in preparing the teaching material and the assessments. As Sarvajna provides real-time analytics on student performance, including karma points, XP points, difficulty progression and leaderboards. Based on this ranking, using these analytics, faculty can quickly identify which students are too good in their subject and who are really struggling, enabling early academic risk reduction and timely intervention. Additionally, automated evaluation of the quizzes and the coding submission have significant grading time, allowing the teachers to focus more on teaching and mentoring rather than manual assessment. Thus, instead of forcing the students to adapt to the curriculum adapts to the student here in Sarvajna AI. Each learning interaction becomes a very easy and very lively that improves the learning system itself. Sarvajna AI transforms the classrooms into self-evolving learning ecosystems through document understanding, LLMs, automated assessments, adaptive learning analytics to transform traditional classrooms to AI-powered intelligent learning environment. Thank you.